Hello and welcome to the second part of our tutorial series How to Get Started with UOS. In the first part, I gave you an overview of UOS and its functions and showed you that a device with UOS is much more than just a controller for automating machines and plants. Nevertheless, automation is of course one of the core tasks of a UOS device such as the U-Control. Therefore, in this second part of our tutorial series, I would like to show you how we can use a U-Control with native CODESYS as a PLC. This requires some preparatory work. First, we need the CODESYS development system on our PC or notebook. This is used to create the PLC project. In addition, we need the CODESYS package for Weidmüller UOS for the CODESYS development system so that we can use Weidmüller devices in a CODESYS project. Finally, we need the appropriate CODESYS runtime for the UOS device so that we can execute the created CODESYS project there. Let's start with the CODESYS development system. Since native CODESYS is used under UOS, we can download this development system directly from the CODESYS store. At store.codesys.com, please select CODESYS development system and download the 64-bit version. This download requires a login in the CODESYS store. If you are not yet a CODESYS customer, you can create an account here or log in directly if you are already registered in the store. Once you have successfully logged in, you can now select the 64-bit version for download. First, you will be shown the license conditions for the use of CODESYS software, which you will need to agree to in order to start the download. Once the download is complete, you will find the exe file for executing the CODESYS installation in your download folder. Please run this file and the installation will start. After accepting the license agreement and confirming that you have read the release information, you will be asked whether you want to perform a complete or custom installation of CODESYS. In our example, I will select the complete installation. The selected installation will now be performed. Once it is complete and you have clicked on Finish, CODESYS will appear as an application on your desktop. After successfully installing the CODESYS development system on your PC or notebook, we will continue with the second item on our preparation list, the CODESYS package for Weidmüller UOS. To download the latest version of this package, please visit our Weidmüller website at weidmüller.com. You will find our support center at the top of the page. Click to open it and you can now search for the CODESYS package in the search field, for example by entering the search term UOS CODESYS package. As a result, you will see the appropriate UOS package versions for CODESYS. In our example, we want to select the latest version and download the corresponding package. Once you have extracted the download files to a suitable folder, you will see a package file in your directory. I have placed this package file on the desktop for demonstration purposes. Double-click on the icon to start the installation. If, like me, you already have several CODESYS installations on your computer, you will now be asked which CODESYS version you want to install the package for. Of course, I choose the latest version I just installed. After loading the metadata, the licensing conditions for the Weidmüller UOS package appear. If you agree to these and confirm that you wish to continue despite of the missing signatures, you can proceed with the installation, and the package for Weidmüller UOS will be installed for the current CODESYS version. This package installation completes the second step of our preparatory work for CODESYS, which brings us to our final step, installing the CODESYS runtime on our UOS device. This runtime can be found in the Weidmüller Support Center. I enter UOS CODESYS runtime as the search term, look for the latest runtime version in the results window and download it. This will give us a zipped file. After unzipping, we see various SWU files for different UOS devices. Since we want to use CODESYS on a U-Control M4000 in our example, we will use the file UOS app CODESYS UC20M4000 for the software installation under UOS. To install the CODESYS runtime on the U-Control M4000, we connect our computer to the M4000, start a web browser and open UOS by entering the IP address of the connection port. After entering our login details, we are taken to the UOS home screen. The installation of the CODESYS runtime is now performed in the same way as a firmware update, which I already presented to you in the first part of this tutorial series. We open the UOS Control Center and, under Software and Updates, Click on the Update and Installation button to open the window for executing software installations. Now drag the file for the CODESYS runtime for the M4000 from your Explorer into the image window and the installation will start automatically. This installation and the automatically performed restart of the UOS device will take some time. When restarting, you will receive messages such as your connection was interrupted or something similar, because the connection to your web browser is interrupted during restart. Please be patient and do not switch off the UOS device. As soon as the connection is re-established, you will see the update and installation screen again, even without taking any action yourself. Let's go back one page and take a look at our UOS home screen. As you can see, the tile for CODESYS is now also visible under Apps. If we now open the App Manager in the UOS Control Center, we can see CODESYS as a loaded app with the status running. If we had loaded a project in CODESYS that also contains a CODESYS visualization, we could open it by clicking on this tile. Okay, the preparations for CODESYS are now complete and we can create our first small CODESYS project. To do this, we open the CODESYS development system on our computer and create a new project. For this purpose, CODESYS offers various templates for a ready-made project framework in addition to a simple empty project. I select a standard project here and give this project a suitable name, in this case simply test. We are then asked for which device the project is to be created. Here, we can select the appropriate device from a list of available devices, in our case the already suggested uControl M4000. We also have the option of selecting our preferred programming language. Since CODESYS offers the option of using different programming languages for the individual programs or functions within a project, we can still change the languages later in the project if necessary. I'll start with my preferred programming language, structured text. The project is now created according to my specifications and a predefined project tree appears on the left-hand side. As a first step, I want to configure my hardware, that means tell the system which uRemote input and output modules are connected to the system bus of the uControl M4000. By double-clicking on System Bus, I open the corresponding hardware configuration. This is very similar to the UOS I/O configurator, which I introduced to you in the first part of our tutorial series. However, unlike the UOS I/O configurator, there is no scan button here. But we can easily select the connected uRemote modules from a catalog using drag and drop. On my starter kit, I have 2 digital modules directly to the right of my M4000, one uRemote module for 8 digital inputs, and one for 8 digital outputs. Now let's move on to the analog modules. First, one for 4 analog inputs for voltages and currents with 16-bit resolution. And finally one for 4 analog outputs, also for voltages and currents with 16-bit resolution. All that's missing now is our temperature measurement module with 4 channels and diagnostic function. That's it, done. Where necessary, the uRemote modules used on the system bus are configured now as the next step. In addition to the graphical representation, the modules connected to the system bus are displayed to the left in a tree structure. By double-clicking on a module, I get more detailed information about the module and can configure it, for example the analog input module here. Here I now specify that I am using a measuring range of 0 to 10 volts. And for the temperature measurement module, I specify which temperature sensor is used. In this case, it is a PT100 with a measuring range of -200 to 850 degrees Celsius. I would now like to create a small program for testing purposes that converts these 2 analog values into real values. To do this, I first create a global variable list. The suggested name GVL is fine for me, so I click on Add to create this global variable list. For my test program, I now create the variables for the values directly from the analog input modules. First, I analog input channel 0, which is provided by the module as an integer value, and I temp sensor PT100, also as an integer value. And now I create the variables for the converted values for these input values. First, analog 0 to 10 volts channel 0 as a real value and then outside temp channel 0, also as a real value. Now we will perform a mapping to assign the 2 upper integer variables, with their values coming directly from uRemote modules, to the corresponding channels on these modules. First, let's take a look at the analog input module. Under I/O mapping, I select the appropriate variable for channel 0 from the global variable list. And for the temperature measurement module, I link channel 0 to the integer variable for the temperature from the global variable list. Okay, now we can write the actual program for converting the analog values. First, for the voltage value from 0 to 10 volts. Since we get a value between 0 and approximately 27,650 from the analog input, I simply divide this value by 2,765 to obtain a value between 0 and 10. However, we must ensure that the result is of type real. But the value from the module is an integer value. Therefore, we perform a type conversion from integer to real for the value from the analog input module. We also perform this type conversion for the temperature value from the module. This gives us an integer value in tenths of a degree Celsius, so we simply have to divide this value by 10 to obtain a value in degrees Celsius. The test program is now complete. I will now save it and establish a connection to the U-Control M4000. To do this, I select the M4000 and scan the network for this connected device. The gateway recognizes the connected device so that we can access it. Now we generate the code for the connected M4000 from our project and go online. When connecting for the first time, CODESYS recognizes that no user management has yet been created on the M4000 for this connection. So we now create an administrator for this connection and assign a password. I use the UOS login credentials for this. We are then prompted to log in to the M4000 with our login credentials, for which I again use the UOS login data. Since no application is currently running on our M4000, we are asked if we want to create an application from our project and download it. Of course we want to, so yes, the application is then loaded onto the M4000. To start the program, we now start the PLC and can view the program in online mode. Here we can now see the program lines with the online values of the variables. Let's take a look at the first line. The analog input for voltage is connected to a potentiometer on my starter kit. I turn the potentiometer all the way to the left and get a value of 0 from both the module and the converted voltage value. So far, so good. I now turn the potentiometer all the way to the right and get the maximum value from the module, which corresponds to a converted voltage value of 10 volts. Great. Now for the temperature value, I get the value 317 from the temperature measurement module, which corresponds to 31.7 degrees Celsius. I now heat up the PT100 and see what happens. The temperature rises. As you can see, the little test program works. All right, test complete. I will now log out of the M4000 and close CODESYS, saving the test project. Finally, let's take another look at our UOS home screen. Here, we notice that the tile for the UOS I/O configurator now appears grayed out. It is no longer possible to select it here. This is because the hardware configuration created under CODESYS takes precedence. When a CODESYS program is loaded, the UOS I/O configurator is therefore deactivated to avoid possible inconsistencies between two different hardware configurations. Okay, in this video you have just seen how a U-Control can be used as a PLC with native CODESYS. The most important points are briefly summarized here once again. We have seen how to download and install the CODESYS development system. We have installed the corresponding CODESYS package for Weidmüller UOS so that we can use Weidmüller devices and modules in CODESYS. We downloaded the CODESYS runtime from the Weidmüller Support Center and installed it under UOS on a U-Control. And we created a small CODESYS project and used it to test the installations. In our next video in the How to Get Started with UOS series, I would like to show you how to create a visualization under UOS using the web-based visualization system ProconWeb ES. Stay tuned and see you then.